So in the previous video, we have seen about basic descriptive statistics. So that is about mean, median, and mode. So before moving on with the measure of variation or measure of spread, we'll learn about a few terminologies which might come in handy later on. So basically here the first thing is something known as bimodal. So the data on the like an image over here. So let us take with the example itself. Okay, so the data on the right shows that there is data of occurrence which is two of them having the same occurrence. Okay, so example over here is like the sale of beverages from a shop. The data is most likely to look something like this. Okay, so the sale of coffee and tea are most likely to outrun than the others before. So okay, so this is the analysis data of a small shop owner. So who wants to know like which are gonna run out first. So basically he can just check with respect to the mode of individual items, and by the graph over here also we have 2 points where it is occurring with the highest frequency. So the number of orders which are given for the beverages, that is like the coffee and the tea, are high. So it's like more of you it's like the consumption of tea or coffee is comparatively more with respect to other things. So maybe you can have ask whether just the tea, or maybe maybe here beverages you can consider like green tea and other stuff also. So they're highly preferred is just the plain tea or something like that. And with respect to coffee, now since we have seen this curve over here, so you can find out the median over here also. Okay, so the median would lie somewhere in the between. Okay, so you can see there is a downward trajectory, so that would be a median. So again we need to put down in sequence, right? So when you put down it in terms of ascending orders, definitely it will be somewhere around this value. Okay, so the again median would suffice with respect to restocking of the data. Okay, so in this scenario you will be using mode, and you can have multiple. So it's just not like taking with respect to this and replacing that, and also like he or she should take care of what are the other beverages which are getting quite a very basic example with respect to my model over here. So basically the idea what we want to take from the terminology of bimodal is that there can be multiple, or like there is multiple data which will be having similar or very close by occurrence of the frequency. Okay, so that is about bimodal. And next we have the bell curve. Okay, so it's like the normal curve. So basically the name of the curve is because it resembles of a bell, so you can see in a second. So the bell shape of the curve portrays the symmetric of nature of the curve. Okay, so example, if we pick a random group of people from the crowd of all age group. Okay, so you can have all age group, and then you wanna just check with respect to, we'll find that the most of them in this age would be like some 30 to 50. Okay, so a person having age 80 or plus, or maybe you can consider a kid who is having a 10 or low, would be very less when compared to this proportion. Okay, so maybe if you draw a graph over here, something like this. Okay, so in here it's there is a term known as standard deviation. Need not to worry. So this is nothing but the deviation from the mean. Okay, so we'll be learning about standard deviation, or actually the variance terms with respect to spread of the measure of spread, which we will be looking in the next video. So basically here you can see this curve is some kind of a bell shape over here. Okay, so basically it is bulging out at the middle. So this will be our zeroth, you can consider, and from there how the data is deviated from the mean of it. So basically you can consider this as 0, and from minus 0.5 and 0.5 there is like kind of 19.1%, 19.1%, so something like that. Okay, so this is a random data curve. Okay, so you can consider this also age 30 to 50 if you are drawing from 0 to 80. So you will probably have some thought like similar graph when you're just plotting it with respect to this. But if you're plotting a standard deviation curve, you will end up something like this, which is have a bell shape, and definitely it will portray a lot of symmetric nature of the curve. Okay, it might not be exactly symmetric as shown in this example, but it will show some level of symmetricity. Okay, so that is about the bell curve. And next we have skew data. So basically skew data here is nothing but this one. So we have two directions. So basically on the left hand side we have something like a data which is like, maybe you can consider the mode of it. So the frequency is going very high, and definitely getting all the average values of these is nothing but mean. So mean is somewhere over here and median is somewhere over here. So this is something known as skew data. Okay, so in this also we have two things. So one is positive direction and another is negative direction. So I think the this one is only telling. So basically to remember it in a very simple words, so we have negative skew as where mode will be greater than median and median will be greater than mean. Okay, so this is what it will be represented. So basically for a negatively skewed, and for a positively skewed the mean would be greater than median, which is greater than mean. Okay, so you can see here itself, the positively skewed the mean is greater than median, which is greater than mode. Okay, so negatively skewed, it is the vice versa. Okay, so with respect to graph also, I think the data is a little clear over here, and the real data or real life data accumulation, if you just draw a graph like this, might not look similar, but ultimately you will be having 3 points, which is like mean, median and mode. Okay, so over there you will be having kind of positive direction or negative direction skewed. Okay, so those are the three main terminologies which I wanted to discuss, which might come in handy in the future. So that's all with respect to this video. In the next video we'll be learning about the measure of variability or the measurement of the sprint.